Thank you. First of all, I'm glad to be here. As Nigel said, my name is David Mesa. I am the Chief Knowledge Architect at NASA. I'm stationed out of Houston, Texas in the USA. First of all, thank you, Nigel, James, Ziggy, and the rest of Data to Value to invite me here. I really appreciate that. Great opportunity for me to get up here to London. First visit to London. Really enjoying it so far, and I plan to get out there in a couple of days and really explore your fine city here. So, a little bit about myself so you kind of understand where I've progressed through the years. Primarily an IT background, 25 years in IT, doing all different types of development within IT, all the way back to Windows development. Used to be an old SQL, and actually, anybody remember Access 1.0, 2.0? Yeah. I was developer in Access before I went to SQL and developing Windows applications. I never thought at one point that these web applications would take off. I was basically a Windows developer and realized that I made a big mistake and dropped that and started going into a lot of web development. About 5 years ago, I was asked to join the knowledge management group at NASA. For those of you, knowledge management is just the strategies behind how you take data and turn it into knowledge. So what I'm going to talk today a little bit about today is why connected data, why we're here, a little bit about my path to lead the knowledge management group to this world of being able to connect our data together. And then I'm going to talk to you a little bit about knowledge architecture, well, how I define knowledge architecture, kind of a position I created for myself at NASA to be able to take this information and really turn it into valuable knowledge. We'll look at some opportunities that I think we can use this type of information in, and then I'll have a little time for questions at the end. So connected data, why connected data? As you can see, this is just your standard star chart with all the different constellations up there. We've been using this for centuries, years. Sailors back used to use the Big Dipper with the North Star, trying to locate themselves, get directions. So we've been using connected data for numbers of years, for centuries, way before back we knew what it was called. The main reason is because our brain works on connected data. Our brain is probably the largest connected data or graph, network graph we have available. Throughout there you have a bunch of entities inside of there with a lot of connections firing back and forth. That's how we visualize, that's how we see things. And we see patterns, our brains see patterns a lot quicker than trying to read through a list. So utilizing graphs, utilizing connected data allows us to see information a lot easier. So, and why is this important in our organization? I always start off with a little introduction to knowledge architecture and the value of information. Peter Drucker, back in 1999, a real famous business management analyst, said the most important contribution management needs to make in the 21st century is to increase the productivity of knowledge work and the knowledge worker. It's important because we've got such a great explosion of data. Gartner analysts back in 2012, I believe, said that by 2018 there's going to be an 800% increase in data. And 80% of that's going to be unstructured. I think they're going to fall well short of that mark. I think I think that mark itself is well short of where we're going to be. It's going to be much larger than 800% back in 2012. So we've got a lot of data coming out there, and unstructured data is probably our greatest amount of information. You see it on social networks. You see it on in your customer logs and your customer information. We see it all the time in our project reports. And right now we have a very difficult time getting that information out of our projects. I'm going to show you how we're trying to get that information out of there to give our engineers, our scientists, our medical doctors the ability to get that information a lot quicker as we go through it. And how do we do this? Well, let me talk a little bit first about challenges as we go through here. Give you a little idea of what's going on at NASA. Down at the map down here, you see all the different centers we have out there. We have 10 centers and about another 7 or 8 facilities. So about 18 different locations out there throughout NASA. We have hundreds and hundreds of millions of documents that get generated, each and every year, and it's just growing. And it's growing by leaps and bounds. You got the, what are we up to now? 5, 7 V's in defining big data. Used to be volume, veracity, and variety. Now they've added, value, and they've added so many different V's to try to make. Bottom line is, big data is just getting bigger, as far as the problem is. Now, I define big data a little bit different than most folks. If you don't have the computing power to take care of your data, doesn't matter whether you've got 10 gigabytes or 10 petabytes, it's big data to you if you don't have the ability to take care of that. So don't think just because you have 10 gigabytes and you don't have big data, you do. And you have an issue there, you got to look at it, you got to figure out how to handle that information. Of course, we've also had problems with the accessibility of our engineering data sources. I don't know how you guys have with your organizations, but most engineers we found have to try to look at 13 different sources to try to find the information they're looking for. And even then, they're still not finding it. So we'll talk a little bit about some of the opportunities in search to help those engineers do that. And of course, our visibility is limited. Primarily, our visibility is limited because engineers and scientists are very protective of their data. They don't want to let it go, so we have a lot of siloed data. And that's another area that we have to try to break through as we work through our issues. So, talk a little bit about knowledge architecture and how I define knowledge architecture. Knowledge architecture to me is a combination of 3 different disciplines: knowledge management, information architecture, and data science. Knowledge management is a strategy primarily that we utilize in order to turn that data into knowledge. All the different strategies, whether it's lessons learned, case studies, pause and learn, different types of techniques that we use to make sure we capture and store and make that information available to our end users. Information architecture are the pipes or the data that transmits the data to the end users. That's the enabler, that's the IT group. Data science is the methodologies, the algorithms, the models necessary to transform that data into knowledge. Okay, so you got knowledge management, which worries about the knowledge, information architecture, which moves that data, but then it's data science that transforms that data into knowledge. If you don't have all 3 of those, you're going to have a difficult time trying to extract that information or that data knowledge out of your data. I've worked with a lot of organizations. I've worked throughout in different centers at NASA. Everybody has generally all of these within their organizations. More often than not, they don't work together. And I'm going to tell you a little story. I'm not going to read all this to you. You guys can look at the slides. But why they don't work together. But when I told you 5 years ago, when I first started in the knowledge management group, they were having a bi-monthly meeting. We go in and meet with the taxonomists, my information group, my information architecture group, and our data sciences group. They get into the room and they start talking, and within 5-10 minutes I realized we had a real big problem here. The taxonomist is talking about needing metadata, wanted to make sure there was metadata attached to the documents for the classification and organizing. Okay. The IT guy was saying, we got all your metadata. It's all there, no worry. No, we don't have metadata. So they went back and forth for 5 or 10 minutes. And I realized that even though they were using the same definition of metadata, data on the data, they were talking about 2 different things. The taxonomist was looking for metadata on the documents, the title, the author. Was there an abstract? Was there information about those documents that could help them classify those documents based on their taxonomy or in their ontology? The information architect was looking at the metadata as far as the size of the file, whether it was Boolean, was it string, what was it? Yeah, so, but more like from a database developer type. So while they were looking at this, talking the same language, they were totally missing each other. And that's kind of with the birth of when I started thinking about knowledge architecture. You need to have a group, an individual, a group of people that can talk all 3 of those languages in order to be able to communicate across each other. Once I started to get them to understand that they were really talking about 2 different things and got them working on the same page, we started to move a little forward. So you really need to look at your knowledge architecture and define that and try to understand how you can work with all 3 different groups. And why is this important? This is Eric Schmidt, formerly of Google, made this comment that we have an opportunity because there's so much information out there. It's ubiquitous information, and information is power. Now I'm going to play the semantic game here because I'm going to challenge that because I don't think the information is the power. It's the knowledge you get from that information that's the actual power. And I know that's again, I'm playing with words here, but I just want to stress a point. You can have all this information, but if you're not able to take that information and turn it into something that's useful to your end users, then you haven't done nothing but just store a lot of information. So you have to make that information. But with this great power of information comes a great responsibility. That responsibility belongs to you guys in order for you to be able to take that knowledge, that information there, and turn it into viable knowledge. Do it in a way that your users can actually see it. They can develop the patterns, and they can use that information within their daily work, whether it's more from a consumer base, or whether you're working internally from a technical or project management aspect. There's a lot of work that can be done. It's up to you guys to be able to do that. So let's talk a little bit about areas of opportunity. And if you guys have any questions, feel free to chime up in the meantime if I can answer something. So as I look at my opportunities, I decided to focus on 3 different opportunities or areas that were giving me headaches. One was search, and we'll talk a little bit about why that's such a big headache. The other one was storage, and then data-driven visualization. By data-driven visualization, I mean using the data to drive how you visualize that to your end user, not the other way around, just giving a visualization and putting it out there and hoping that it meets the end user's needs. And these are the different types of aspects. I break up knowledge architecture into 4 different layers. Access and storage, where you'll see all these different types of databases or access storage, whether you got graph databases, document databases, your standard relational databases and flat files. Integration, how do we actually get that information out of the data sources? You've got your analysis, where you do your different data modeling, your data science technique, you use your algorithms, and there's so many different types of possibilities there for doing models, whether it's R, Python, MATLAB, SPSS. There's a lot of different tools that are available out there. And of course, at the end is visualization. That is the real key to me. At least that's the area I focus on, because we fail a lot on how we end up visualizing it. More often than not, when you get into a website and you try to find information, what do? You get pages and pages and pages of lists of different documents. You've got to click on each and every link to make sure you get to the right information. We can do better than that. So let's talk about opportunity number 1, search in the enterprise. And I want to differentiate between search in the enterprise and search out in the public, because it's 2 different things, because Google's really spoiled us on how we find information. I constantly, when I walk around the center and I talk to people about search, I say, what do you want? What do you want out of search? We want it to be just like Google. Well, I'm sorry, we can't do that. And I'll explain to you why in a minute. But here's the reason that search to me is very, very important. 46% of our workers can't find information about half the time. That's impressive. 30% of total R&D funds is spent to redo what we've already done once before. And I'm going to give you a story in a minute how that being able to improve upon our search helped us there. And then 54% of our decisions are made with incomplete or inconsistent or inadequate information. That's scary, especially in my line of work when we're trying to get people up to Moon and Mars, and we're only using the 54% of our knowledge to be able to actually make decisions. We have to improve upon how we do that. So one of the reasons Google doesn't work for us. More often than not, Google is a keyword search-based engine. I'm going to be very high level here, and I'm going to oversimplify it. And I've done this presentation in front of Google folks before, and they basically nodded their heads and said, we totally understand, we totally agree. So I'm not saying anything that they're going to argue too much about, but primarily when you take a document, you put it in there, they break it up into keywords, and then those keywords get basically put into the algorithm, and it's broken down, and it becomes nothing but a bunch of keywords that you look for in your documents. And while in the public it works, because Google's algorithm, basically what they do, they index everything. First off, we can't afford to index everything. Over a couple 100 million documents, we probably only index 10 million. So it's not a whole lot of it. It's 1/10 of our known data are we able to index. That's all we can afford to do. We used to have a Google search appliance. Then they apply about 200 different algorithms on top of that to try to model it, classify it, organize it. Then it's up to the users by page ranking. The more oftentimes the page is clicked or linked or selected, the higher it goes up in the rank, right? Well, again, that works if you're Google. Google gets 5 billion queries a day. So from that aspect, you can develop a very good model that's going to tell me within certain standard deviation, if I'm looking for something, I'm going to find it right there at the top of that curve because of the 5 billion queries a day. I'm sorry. On my aspect, in JSC, Johnson Space Center, we have 1,000 queries a day. There's probably 10,000 people at Johnson Space Center, and maybe we get 10,000 queries a day. And this is where the semantic part of it will help us as we go forward, because we may have people that are looking, I'll take for example Mercury. I have 3 different ways of looking for Mercury. Mercury the planet, Mercury the element, or Project Mercury, which was a program back in the late 50s, early 60s of a rocket ship that we were testing as we're getting ready to go to Apollo and onto the moon. Well, if somebody's been, a scientist or a doctor's been looking for Mercury the element, or looking at or an astrophysicist looking for Mercury the planet, that page rank is going to be way over here. It's going to give me a selection up at this top of the curve on the left-hand side. But what I'm really looking for is something on Project Mercury as an engineer, something that hasn't been looked at for 50 years, I'm never going to find it, or it's going to be on a list, 200 pages down. It's going to make it very difficult for me. That's why I believe Google in the enterprise, or keyword-based search in the enterprise, applied like this, will not work. We have to do something different. So we went ahead and we started doing some evaluation. I got my team together and I said, let's try to figure out what we can do. How can we look at search? So we looked at many different types of search: faceted, semantic search, computational, cognitive, natural language queries. And we did a lot of identifying the different types of search. We really figured out there is no one solution. You have to use a hybrid approach depending on your data. And you're really going to have to decide more on your ability, your funding, and what you can utilize in the different types of tools that are out there based on the data that you have. But some of the essentials there are you should have a master data management plan of some type. Work with your knowledge management group, work with your taxonomists, work with those people that help you understand and get a data management plan into your organization to understand how you're going to capture it, how you're going to store it, how you're going to use it. That way everybody's kind of on the same page. We're constantly having problems across NASA with all the different centers. There's a common theme that usually we go to a center, it's a kind of a running joke. If you've been to one NASA center, you've been to one NASA center. It's because we're totally different. Everybody does everything differently, all the way down to our IT. It wasn't up until about 5 years ago that I could actually connect to some of the other centers because they were blocking the IT, different protocols. At one time it was Cisco versus Novell, and we had a lot of issues there. But we're getting better. We're starting to work with others. We're trying to communicate with each other. The other thing is focus on your critical data. Don't try to do everything. What's important to you, your organization, your people? I looked at our search engine and our search logs, and they were really trying to focus on everything, the easy things, which were quick FAQs, frequently asked questions, or how to apply for scholarship information, things that really weren't necessary to the engineers and the scientists. We need to focus on your critical data. Develop standards across your organization. Now, for my aspect, we have a lot of contractors. At JSC, there's probably, besides the U.S. government that runs the NASA facility, we also have about 50 contractors that work there. So you have 50 different ways of doing things on top of the many different ways that the government does. So try to develop standards. Now in your organization, if your supply line, you may want to make sure that up and down your supply chain, everybody's talking the same type of language so you don't have that confusion back and forth between each other. So that's fairly important. Analysis is essential. Don't just think that the tool that you purchase or utilize is going to do it all for you. Get some data scientists in your group. Get some folks that can do the algorithms, that can understand within that black box that people are trying to sell you, that you'll have an ability to make some of the decisions yourself. And metadata. And actually I need to stress that metadata is because if you don't have that metadata, that data on your data, it'll make it even harder for you to find things. So make sure you have a good way of collecting that metadata within your organization. And some of the analytics that you can do on that, on your document, you can pull out entity extraction, get some of those information and apply that back to your documents through those analysis. Those are quite helpful. Do parts of speech type of analysis. So in talking to our users, these are the type of things they were looking for. As you can see, nobody in here said keyword search. They wanted Google, but when they really started talking to them and asking them, they didn't say we want keyword search, we want semantic search. We want ability to connect between what we're actually asking for. If I'm saying Project Mercury, it's going to understand that I'm talking about a program or a project or an engineering, not a planet or an element, because of the words that are connected together can get me to the point of what I'm really looking for. Cognitive computing is also something you need to look at, and that's where we can do things like clustering or topic modeling in order to extract. And I'll give you a quick example a little bit about topic modeling and how we were able to use that in our lessons learned database for a particular engineer. Faceting. If you're not familiar with faceting, you do it all the time in Amazon or some of these other where you're looking for a TV and then it's actually what type of TV and you break it down. Those are your facets. They wanted some type of facets. A key point, at least in my analysis, was repository-specific searches in your organization, of course. Make sure that you're looking at particular information. A group of engineers, or particular engineers that may be looking at more from a propulsion system, really don't want to look at medical information that came from a radiation analysis. They really want to have specific information in what they're looking for. So as you identify your critical data, make sure you understand where those repositories are and be able to build indexes on your searches based on those specific repositories. You can search them all if you want, but the ability to get down and look at specific searches as you go through that. Of course, to save time, they want to be able to save searches and they want to have alerts. And alerts basically, if a new document gets put into that index, it tells the person here a new document that met your previous criteria is now available for you to look at. So those are some of the things. And that's kind of my highlight approach is to knowledge architecture and what we do. But kind of gives you an idea of how we apply that to search. So time for a little story. Kind of goes back to the search. I had a very sad engineer. And this is a true story. Happened about 6-8 months ago now. The Orion project, which is the next capsule we're trying to get up to as we go to Mars, they were doing a test. And the Orion is fairly similar to the old Apollo. If you remember the Apollo, when it would come down, it would land in the water, and these big balloons would open up and upright the Apollo system, the Apollo capsule. Well, they're doing a test on the Orion, and we had a partial failure. So one of the balloons did not open up, and so they had to figure out what could they do. How could they find some information in order to redefine or redesign their engineering work on this capsule in order for them not to be delayed because they were having a problem. So in doing this, they went and searched everything they could through our standard Google search appliance search. They spent hours and days, actually 2 or 3 weeks, if I remember, trying to look through all the information. But if you remember, only 1/10 of our data was indexed. So they really weren't looking at the right information. But they didn't know that. So then they went to our JSC historians. They were the keepers of everything that we've had over the last 60 years. The historian, unfortunately, had a kind of another keyword-based search capability within a database they had, and they can only get a keyword off of the title, and that was it. Nothing internally within the document. That historian spent 8 hours looking for information, found 3 documents. Spent another 3 hours trying to review those documents to see whether they were of any value, because some of these documents are a couple hundred pages long. So they had to try to search inside of there to get that information. Very, very difficult for them. The engineer even went so far as to go and look for retired engineers, go to their homes, talk to them, and a couple of them said, wait a minute, I got some documents up in the attic. And brought them down. He was getting pretty frustrated. They were looking at having to redo the whole thing. It's going to take them 2 years to do a test article for development testing and probably spend a couple of $1 million. So here's where the white knight comes in. That's me. You haven't figured it out yet? We were having we were doing a pilot of a application that allows us to do everything I just talked about, semantic search, clustering, a lot of different things. I had included the historian in on this, the JSC historian, and she said, well, look, went to the engineer, why don't you try to utilize this tool? The engineer went in there, went to the tool. Well, first of all, this is our standard search capability that the engineer went through. Typical Google, search appliance, all the different links. You go down here, and there's some things about uprighting system, but they're very, very current. Maybe a photograph or something that was talked about in an article or something, so not any real good information. This is what my application will look like that we were prototyping. And in here, you have right down the center, if I can do that. Right down the center here is your kind of your keyword search with a lot of semantic type information connected to it. There's the Apollo uprighting system. Excuse me. The other benefit of this, it takes you right to the point of the document that query is answered. So rather than having to read through 200 pages, you get right to your point. On the other side of here, you have your repository-specific search. You can click in here and tell it which repository you want. You have your save your alerts, everything that we talked about from our requirements. Here's how we can facet it. If there were more indexes that we were looking at, we'd have more facets here, but since it was one repository, it's one limited. And this is where our cognitive computing, our clustering, our topic modeling, we have a lot of different parameters, cause and effects, that we can make the connection semantically back and forth to this upright system. Here we got uprighting system made up of a compressor, inflated bag, or an airbag. So as you see, the engineer can focus in on the information he wanted. In 3 hours, he found 200 relevant documents. In the first 10, he found the answer he was looking for. We saved him those 2 years and $2 million at this point, looking at this. So needless to say, my management was very happy. and we're going forward to implementing this into production. So very, very good tool we were able to utilize. But again, primarily because of the way it was all linked together, the connected data, the semantic, the clustering, the ability to do all of this within your search appliance. And you're going to hear a lot more throughout the day from some of these fine speakers that I looked at that'll give you more detailed information. Kind of want to give you an overview of everything we've done, kind of set the ballpark here. So rather than searches for things like this is a standard Amazon search for a graph drawing book. We want to be able to search like this, which is another way of doing it. Same return as this, but more in a graph, in a connected model. Here, it's the same book with all the information here, and you got your list over here, but then it's grouped by different types. Over here are more about, I believe this is JavaScript and writing, and down here is graph theory, some analytics. Up here is how to program, and so you can easily, as a end user, you can jump to the areas you're looking for rather than having to go through a ton of lists to try to get information. Most users like this a lot better than I found than having to read through a whole bunch of lists. So let's talk about opportunity number 2, storage and access. I'm going to focus on the top 2, document databases and graph databases, primarily because working in a small team right now, these are the easier things for me to work through. As I start to develop some of the more wide column, the Hadoop and the key value. So if we look at a graph database, a document database to graph, we're looking at taking our information that we currently have, putting it into a document type database through a connector that, in this case, Neo4j has developed, I believe, between MongoDB and Neo4j. You can actually create a graph on the fly from your documents as they get ingested into the document database. So we've done this. We're right now, I have a couple of interns actually working on this to get the information of our lessons learned database into a graph. So it automatically puts it into the graph. And then you start seeing patterns start to emerge. We start seeing this is actually a quick graph of our ontology, a subset of our ontology on spacecraft. So we can see where the different spacecraft are connected, who's developed it, what industry or what company is working on those spacecraft if we go through that. But you can see those patterns. And the main thing is that as you start doing this connected data, you start seeing all these patterns come up and you're able to find that information a lot faster. And of course, if you can find it a lot faster, you can make decisions a lot better to go forward. So, story number 2. This time we have an inquisitive engineer. Young engineer, and one of our practices for any new program or project that we start is to go look at the lessons learned database to see what has happened in the past, how we can utilize it. So this engineer had 23 different key terms that he wanted to search against the lessons learned database. So he went to our standard JAC search, which I showed you earlier, and he had to put in each key term to look through the list and have to look at the entire list. Now, if you remember, we indexed 10 million documents, not just the lessons learned database. So he was trying to have to pick through what was the lesson learned, what wasn't, and he was spending a lot of time. So he came to me and said, hey, can you do something? Well, let me go talk to the IT guys, the search team, that can you guys just give me an index of the lessons learned database? And then apply these key terms to it and give it back to me. Yeah, we can do that. A couple of days later, I got an Excel spreadsheet with 23 tabs, one for each keyword, with a list of all links that the engineer still had to go through there and click and link. I said, no, we can do better than this. We have to do better than this. So here's an example of our public lessons learned database, not the one that I was working on. Well, I ran a model against this, very similar to what I did, but primarily because a lot of our information is classified, or actually sensitive, but unclassified. I'm not allowed to put it out, but this information I can put out publicly. But this is very similar to what our lessons learned looks like. Again, just a basic keyword search. He can only look through it from what type of sensor and maybe a particular date range. So I said we can do better. So here's some of the data science comes in. Apply the topic modeling algorithm, latent Dirichlet allocation. Primarily what that basically does is look at the words within the document and try to develop the frequency of the words in that document to try to develop a topic. At the end of the analysis of the algorithm gets run, you can get a list of a bunch of key terms or words and their frequency and the probability that this document is about these words or these topics. So you start developing a pattern, you start seeing topics. So out of these a little over 2,000 lessons learned, I generated 27 different topics out of that. And through that, I started looking at my model. How do I develop a model apply this into a graph section. So here, I know it might be a little difficult to see, but here are my topics. I created a topic. It's associated to a category because some of the metadata within that lessons learned database, it had a category, a self-assigned category. It contains this particular lesson. It was submitted by this person. It occurred at this center. This topic contains this term. And I was also able to correlate the topics based on their category self-assigned. So now I know how well those topics relate to each other, both positively and or negatively. So I can move across those quite easily as I go forward. So if you put that into Neo4j, you get something like this. Very similar, very easy. I mean, you're going to see this in some of in the future talks. But I'm starting to develop a good database of where my documents are. In this case, the lessons are in green. All these lessons here are in these categories, and my topic is in blue, right here. So you can start seeing patterns as you go. And this is good for a developer, for somebody that's working through, somebody that can do the analysis, write the cipher queries. I needed to find a little bit something better that I can do for the end users. Again, here's a little bit more example of Neo4j. Here again, you have your topics here in your different categories. So I can see this topic, it not only has these lessons in this category, but these lessons over here that are associated with this category. So I have multiple ways my end user can find these lessons, either by topic, by category, and then make those connections. Rather than having to look through a list of documents, he can go to one topic or one category and get all the lessons that are associated with that based on what he's looking for. So opportunity number 3, because as I said, the database, while it's good and I like it, it's good for developers, good for an analyst. If you know cipher queries, we have to give it and make it a little easier for the end user to be able to find this information. Because most of our end users don't want to sit there and learn a new language. They just want to be able to point and click and get some information. So we looked at another tool, which will be talked about a little later on. And we went out here, we predefined some queries for the end user to be able to look for. So in this particular case, we found a lesson. We did a little search through the database, through this tool, to do fuel and oxygen storage tank relief valves. So it's a lesson learned on relief valves, storage tanks, and how we go through that. The end user has all the information they need over here, and then they can click on the link to take them directly to that lesson on our website if they wanted to. But all the information is right here, very easy to see. And if they click and expand, they get more information. So again, very similar to the graph database in Neo4j. Here's the topic it came in, fuel water valve. As you can see, some of these same words are in the topic, so it fairly fell into that topic fairly well. It happened at the Kennedy Space Center. It was written by this gentleman, David Pennington, and in this particular case, the category was not applicable. They didn't assign one at the time. But again, information easier for the end user, the engineer, to go through this. So the engineer was able to go through these lessons learned and find information a lot quicker. Again, as you can expand, he can do this all in one location. Remember, if he was on a list, on a regular Google list or list, he'd have to click each one, open it up, look at it. Here he can see all the topics, all the documents that are associated with that topic, really quickly look at the information here and decide whether it's important to him or not, rather than having to go through so many different pages of information. So very, very helpful to him. Another built-in query we looked at is how the topics are associated by categories. So this particular engineer, in this case we're looking at a topic that's on valve contamination or tank contaminations. And there's 2 different categories. He was actually looking for a category in cryogenics. So he can see that this category in cryogenics, all of these lessons are in the cryogenics categories within this topic. So really quickly he was able to hone in on the information he was looking for without having to search all the information that was there. Sped up his time frame to start the project rather than having to take 2 weeks to do all this information gathering. He was able to do that in less than 3 days and was able to get the project started. So his manager was a little bit more was grateful in the sense that the project wasn't getting delayed. It was happening faster. So actually, it was going a lot faster than they thought it was because of the information they had available. They allocated up to about 3 weeks. He was able to get it done in 3 days. So it's pretty good there. Last thing I wanted to show on this particular type of analysis here, remember we talked about correlating the topics to each other based on the categories. So here's the topic over here, valve contaminations, tank contaminations. So give me all the topics that are correlated to that topic. So it comes over here to another topic on air pumps or damages to air pumps. Okay, I can understand how those two may be correlated, how they maybe work to each other. Over here you got something on fuel valves and water valves. Okay, you got fuel valves, water valves. I can see how that's correlated over here to valve contamination or tank contamination. There's some issues there. But the last item over here is correlated along the line is fire hazard batteries. How does lessons on fire hazard because of a battery correlate to valve contaminations or tank contamination? So I started doing a little digging. I started looking at those documents within that, or the lessons within that topic. But there were several lessons in there that talked about battery leaks, acid leaks that came out of the batteries, or heat buildup that caused a battery explosion, that ended up, the acid got leaked into the tank, which ended up contaminating the tank and contaminating the valve. So on a regular list, these documents over here would have probably been on page 15 or 20. The usual would have stopped somewhere around page 2. Never seen these lessons over here, but on something like this where you're using connected data, you're using your graph databases, you're using your analysis, you're able to make quick jumps from one topic to the other and gather your information a lot faster. Those things have benefited us within our program engineering, within our research, in order to speed up some of the work we're doing, in order to save money, as I talked about in our search. So I'll leave you now with, what could you accomplish if you could take care of all of this and empower faster and make more informed decision makers, because we sped up the time of finding things. We're leveraging our lessons in the past because we're able to actually dig into those information and bring out those golden nuggets of data that we can get that knowledge out of there and reduce the learning curve for new engineers or new employees. You can see they can go through that information a lot quicker because we can group them together within topics or categories. And then of course if we enhance and extend the content and document management system, we get more information out of our data if we're able to apply these tools to it. Contact information, if anybody wants to reach out, I'll be more than happy to answer any questions or connect. So at this point I'll leave that up if anybody wants to write some of that down, but I'm open for questions.
Anyone have any questions at this point today?
Yes, sir.
So did you have any resistance to this? Do people distrust it?
No, there's always resistance with anything that's new.
Oh, sorry.
Oh, 'cause the question wasn't, was there any resistance to doing this, or did people just trust it? Anytime you do anything, especially in my organization when we're working with highly technical, highly skilled individuals that believe they know it all, they definitely take them a little while to get them to understand and be comfortable with the new technology, the new tools. So it was a sales job, in my point, to be able to go out and talk to these different folks in the groups and show them, very similarly how I'm trying to show you guys here, but sometimes a little more detail of how they can get that information out. Fortunately, I stress a lot on the data science because, again, I am talking to highly technical folks. If I can show them I'm talking the same language as they are within the technical world, they tend to appreciate that a little bit more, and they can make the connection a lot faster. If I came in and just try to sell them something on the high level, sweet stuff, I guess, if you want to call it whatever, but they would not take too kindly to that. They really want to see the technical details. Any other questions?
Thank you. Yeah. Thanks for the presentation. I have two questions. One is the shorter one. If you did any UX on the graph presentation, like the edges look a bit unusual to me. I was curious how the people found it and why you chose those types of edges between the nodes. And maybe the longer one is on the clustering that you did. In your first screenshot of your new interface, on the right-hand side you have different clusters that look like relation-based. And I'm curious how you infer those and how you do the clustering.
On the search tool?
Yeah, on your new search tool.
Okay. Let me answer that one first. So on the search tool, if I go back to that, let me make sure. So here?
Yeah.
So this part here? Unfortunately, this part here is part of the application vendor capabilities. So while I ask them for the types of algorithms they use, they don't give me the actual algorithms themselves. But they're definitely doing different types of hierarchical clustering, as well as I believe, if I remember correctly, they were doing some k-means clustering on that, as well as some semantic analysis, parts-of-speech analysis within the documents to try to make the connections. So on the edges, though, you wondered why I chose those type of edges?
Yeah.
It was at that point when I was making the slides, it was just kind of going through the built-in edge link through that. So it really wasn't any major decision on the colors of the types. Is that what you're looking for? Was that
Yeah, more like the shapes of the edges.
within?
Like instead of arrows, you have those. But if it's not part of the application, it doesn't really matter. I didn't realize it was just for the.
In this one or the last one?
No, the following ones.
These?
Like these ones, yeah.
I think you'll have a presentation a little later on about how you can change those presentations from link heroes themselves. I just chose a different color and used the default connections on that. So, but I can change the colors. I can put icons on there if I wanted to, and do a lot of different information, a lot of different ways of doing it. Here I just try to show different colors just to try to pop out that it's a different relationship at this point with the different colors. And they're all bi-directional here, so there's not any one direction.
Hi, I'm Heikel. Yeah, I have two questions. So, when you're identifying topics from a document, do you also try to assert how each topic relate to each other, or just the fact that the document is related to a topic?
Both. I guess first from the topic.
And
modeling,
how do you do that one?
The topic modeling algorithm will define that the actual topic that the document falls in. Actually, when you do a topic modeling algorithm, every document has all the topics.
Yeah.
One topic will come up to the top from a probabilistic set. So you find the one with the highest probability and assign that topic to that document. That's the most likely one. Now, based on the metadata you may have available within these documents, in this case I had categories. I chose the category metadata to those documents. I was able to use that information and the theta value from the topic modeling to correlate those topics based on the category. So that's how I correlated the topics to them. Okay, and I could use any other type of metadata. I could have used other metadata in there to correlate them, create the topics together based. In this particular case, the topics are correlated based on their category. But anything else, I could have. On my blog, I actually write on how I did that in the analysis and the actual codes to write that up and how you do that, if you're interested.
Okay, cool. The second question. So the semantic part now happens on the identification of the topics and the categorization of the data layer. That's what I understand that you guys have been doing. So to what extent do you try to overcome the natural language semantic parsing? So to have the complete semantic search experience, like you go all the way to the natural language parsing part where you actually do the identification of concepts within the queries that the users do to then translate it to the semantic search at the lower level.
Right.
Do you actually try to push to that part?
We're working on that, yes.
Okay.
We haven't gotten there yet because there are some different types of training we have to do to our algorithms to look at the parts of speech or get the entity extractions out so that we can combine the two. We're doing some work on sentiment analysis to try to see what some of the documents or some of the comments. Actually, cool stories. We're working with every mission that's finished, an astronaut has to give a report out on what the top issues within their International Space Station. So we've got years of information that we've been doing sentiment analysis using parts of speech and natural language analysis on top of that, try to figure out what was their most or their worst or best issue, and was there any trend for those issues across the missions? Was it getting better in a particular category or worse? So we are doing some work. We're not there totally yet, but we are doing some work on that. I believe there was a question back over here first. Gentlemen.
Oh, yeah, so it's just a question about technology, really. When you see a lot of these knowledge management projects, the graph technology they tend to use tends to be kind of triple stores generally. I was just wondering why you went down the NEO route, copy graph, rather than
Happenstance maybe, but no, really, it's just when I started doing it from my database background, it just made a lot more logical sense to me. You know, coming from a relational database management world, and when I first started looking at different types of database models, the graph model, the Neo4j, that type of model made more sense to me, and how I can associate and create those relationships to these entities and actually assign properties to those entities. To me, it just worked a lot easier on the world that I'm working on. There was a question here first.
Yeah, I was curious. How difficult was it to actually apply a schema to this? Because graph databases tend to be highly unstructured. Was there a lot of effort associated in figuring out some sort of structure to follow and ensure that the data, when it's transferred, aligns to your model?
Well, one of the benefits of a graph database is that they're schemaless. So you got a graph model here, and as I developed the graph model, if I go back, yeah. So it's really sitting down and talking to your group, talking to your individuals, talking to people that understand or know the data. What's the best way to model this data? So it's some conversation here, and what happens. The good thing is, it's really easy to update. It's really easy to add things to it. In a relational database, if you have a schema and you got to change it again, you could have some problems. In a graph model, it's very easy to add another entity or another part into the model or relationship. It makes it run really quick and easy. So,
But with semantic data, how do you guarantee that you're not adding data that is semantically incorrect if you don't have a model that guarantees the structure?
well, the model itself can be changed, so you can kind of guarantee in the sense that you have control over the model. And I believe, was it you that had a good, Jesus, had a good information on connecting the semantic model in your graph? And are you going to talk about this later on?
I am, yeah.
So we've got a good lead in to Jesus' talk about the semantic and graph database models. It's a good article.
Cool.
Good. That's some great questions there, and it's really challenging, David, and you know, obviously paid great attention to that talk, which was fascinating. Thank you very much, David.
Thank you very much.
Yeah.